let's talk a little bit about some introductions here. So the very first thing that I want to talk about is the definition of the electric current. And so the symbol here is I. And we can just, so there's two ways that you can calculate the electric current. So one equation is called, this is called the average. And this is called the instantaneous. So you can see that the current is going to be measured in a unit called the amps. 1 amp is just equals to 1 coulomb per second. Now, generally, when we talk about current, we're just going to focus on, we're going to really focus on the, so if you look at this, we focus on the flow of positive charges. So this will help us to get the direction of the current. So this is just by definition. So in a real life, in a real system, what is actually moving are the electrons, right? But we use the positive charge just to get the direction of the current. Now let's suppose that, so we're going to derive a very simple equation here that can let us calculate the current. Now, what you see here, again, we're going to use calculus. Now, what you see here, this is just so we're going to look at a wire that is cylindrical in cross section. Now, you can think about this as it could be any system. For example, it could be copper, maybe aluminum. So it could be any of these systems here. But to make the math a little bit easier, we're just going to assume that this wire is in the form of a cylinder. So if this is in the form of a cylinder, it means that if you look at this cylinder, it has a cross-sectional area. Then using calculus, I can pick a small region here that I call delta X. So I want to calculate what is the total amount of charge that I have in this region right here. Now, so every material, it could be copper or aluminum or whatever you want to call it, is going to have this number here, N. And N is the number of conducting electrons. Number of conducting electrons per volume. So this number is going to be given in the exam, so given in the table. So that's the number that we know. So this will be given in the problem for you. So again, N is the number of conducting electrons that I have per unit volume. I'll just give you some examples. So for example, N could be something like maybe 8.5 times 10 to the power 23 electrons. Cubic centimeters. So that's the number that is going to be given to you in the problem. You don't need to worry about it. Now, what I need to do is that I want to approximate how many electrons do I have in this small volume here. And the way you can do that is that if you know n, which is the number of electrons per unit volume, you just need to multiply that by the volume of this cylinder here. And the volume of this cylinder is the area times the length times delta x. That's where you see this term coming from here. So that's the total number of electrons that I have in this volume. And then if you multiply that by the charge of one electron, it gives you the total amount of charge that you have in this volume here. So it's given by that equation. Now, if you know the charge, then remember that if each of these charges is moving with some velocity here, then you can say that the velocity is delta x over delta t. And so you can use that to substitute your delta x. And then solving this, you end up with this equation right here. All right. Let me try to share my screen so I can write this a little bit much more easier for you guys to understand. I think there's just so many equations on this page. Let me share my different screen here. I'll get back to this just in a second. Go ahead and share this with you here. So this is what I was talking about. So let me just make it in such a way that you guys can easily understand. So suppose that you have so think about this as a conductor. And this conductor has a cross-sectional area here. Now this cross-sectional area, if you remember, is equals to pi times the radius squared, where the radius is the distance from here to here. Remember, I'm talking about a cylinder here, a cylinder. Cylindrical. So we're looking at a cylinder. I'm looking at it from one side. So we have a cross-sectional area here.
So the area in all those formulas, that was area, not amps.
Yeah, so this is area. This is area. Right? That's cross area, which is pi radius squared. Now, so we know that, again, we're just going to focus on positive charges here. So there are so many positive charges here in this system. Again, what we know is that we know n. N is the number. If you wish, you can call it electrons, number of electrons. Divided by the volume. So notice that this is also the same as the number of positive charges. Because remember that the number of electrons and the number of positive charges must be equal. Now, using calculus, I'm going to focus on a small, so let's pick a small volume here, such that the distance from here to here is delta x. Then I can say that, what is the number of positive charges do I have in this small volume here? So I can calculate that by taking, if I take the area and I multiply it by delta x, so this gives me volume, and then if you multiply this by n, so what I'm doing is that, so take volume, then you're multiplying this by number of electrons. Volume. So you're going to see that volume is going to cancel with volume, and so all of this is going to just give me the number of electrons that I have in this small region right here. Now, if I multiply this by the charge on one electron, or maybe you can think about it on the charge on one positive charge, then all of this is going to give me my delta Q, which is the total amount of charge that I have in this small volume here. Now, I want to calculate current, and I know that current is equals to so current is equals to delta Q equals to delta T. So it means that I can write this equation as A delta T times N times Q. Then I'm going to call this delta X over delta T. I'll call it V subscript D. So we can write this equation as A V subscript D times N times Q. Now in this case, V subscript D is a velocity that is called drift. So drift velocity.